Hi students, welcome to the maths class. In the previous class, we have studied so many theorems and axioms. I hope that you completed your notes and worksheet. Previous section we have discussed about the corresponding angles axiom and so many theorems that is related to the properties of parallel lines and a transversal. Today we will study about the angles and property of a triangle. You have already studied in your earlier classes the angles and property of a triangle. We know that sum of all angles of a triangle is 180 degree. Now we are proving that statement. In earlier classes, doing some activity or through some activities, we have proved sum of all angles of a triangle is 180 degree. And also, we have studied the exterior angle property of a triangle. We know that sum of opposite angles of a triangle is equal to the exterior angle of a triangle. That statement also we will prove it in this section. In the earlier classes, you have studied through the activities that the sum of all the angles of a triangle is 180 degree. Now we can prove this statement using some axioms and theorems related to parallel lines. So theorem 6.7, next theorem. Theorem 6.7. The sum of the angles of a triangle is 180 degree. You want to prove that sum of the angles of a triangle is 180 degree. So if you consider triangle PQR, we want to show that angle 1 plus angle 2 plus angle 3 is equal to 180 degree. To proving that, we want to construct a parallel line. Construct a line parallel to the side QR. So you can construct a line XY through the point P that will be parallel to QR. XY parallel to QR. So first of all, proving this statement, first of all you have to construct a parallel line through the opposite vertex P. So we can write here what is given and what you have to prove. The given thing is PQR is a triangle. PQR is a triangle. Angle 1, angle 2 and angle 3 are the angles of this triangle. And to prove angle 1 plus angle 2 plus angle 3 is equal to 180 degree. So this is given and this you want to prove. For proving that, we have to start our proof. But first of all, we want to construct. Construction. Draw a line XY. Draw line XY parallel to QR through the point P. Draw XY parallel to QR through the point P. Now, you can use the theorems or axioms related to this parallel lines that we studied in the previous section. Now, when you join this or when you are drawn this parallel line, you can see that there are two more angles are formed. Here you can mark it as angle 4. This you can mark it as angle 5. When you observe this, we know that XY is a parallel line. So if XY is a line, therefore sum of these three angles is 180 degree. They forms a straight line, so this angle is a straight angle. So angle 1 plus angle 4 plus angle 5 is equal to 180 degree. And the same way, XY is parallel to QR. Therefore, P and PQ is a transversal. XY and QR are parallel and PQ is a transversal. Then we know that the Z shape that forms alternate interior angles. So XY parallel to QR and PQ is a transversal. So alternate interior angles are equal. So angle 4 equal to angle 2. Similarly, XY parallel to QR and PR is the transversal. Then alternate interior angles are equal. Here angle 5 and angle 3 are alternate interior angle. They forms a Z shape. So angle 5 is equal to angle 3. Using these, we can prove that angle 1 plus angle 2 plus angle 3 is equal to 180 degree. So first we can write here XY is a line. XY is a straight line. Therefore, angle 4 plus angle 1 plus angle 5 is equal to 180 degree. Give it as equation 1. Now, XY parallel to QR or XPY is parallel to QR and PQ and PR. PQ and PR are transversals. PQ and PR are transversal. Therefore, we can say that the alternate interior angles are equal. Here, angle 4 equal to angle 2 because XY parallel to QR and PQ is a transversal. So, the theorem, we know the theorem, if a transversal cuts two parallel lines such that each pair of alternate interior angles are equal. Using that theorem, we can write angle 4 equal to angle 2. And XY parallel to QR and PR is the transversal. Therefore, angle 5 is equal to angle 3. Angle 5 is equal to angle 3. They are alternate interior angle using the same theorem. If a transversal cuts two parallel lines, then each pair of alternate interior angles are equal. So, angle 5 is equal to angle 3. Now, using this, we can rewrite this equation 1. Angle 4 equal to angle 2. Angle 5 equal to angle 3. So, instead of angle 4 and angle 5, we can write from equation 1. Instead of angle 4 is equal to angle 2. So, instead of angle 4, we can write angle 2 plus angle 1 plus angle 5 equal to angle 3. So, instead of angle 5, we can write angle 3 is equal to 180 degree from equation 1. Now, if you rearrange this, you can write angle 1 plus angle 2 plus angle 3 is equal to 180 degree. What is this angle 1, angle 2 and angle 3? They are angles in a triangle PQR. So, sum of these three angles we got 180 degrees. So, we prove this statement using theorems and axioms. This proof and this theorem and its proof is very important. So, you should study the theorem and its proof with a figure. The next one is exterior angle property. In earlier classes, we have studied the exterior angle of a triangle. In this figure, PQR is a triangle and the side QR is produced to the point S. So, angle PRS is an exterior angle of a triangle PQR. That means angle 4. This angle 4 is an exterior angle of this triangle PQR. We know that angle 3 plus angle 4 is equal to 180 degree. Why? Because they are linear pairs. Angle 3 and angle 4 are linear pairs. They form a straight line. Their non-common arms form a straight line. Therefore, sum of these two angles is equal to 180 degree. They are linear pairs. Then, now only we proved sum of all angles of a triangle is 180 degree. So, angle 1 plus angle 2 plus angle 3 is equal to 180 degree by angle sum property. Or using theorem 6.7. Any reason you can write. You can write here theorem 6.7 or you can write angle sum property. Sum of all angles of a triangle is 180 degree. When you compare these two equations, you can give this equation 1 and this you give it as equation 2. Compare equation 1 and 2. You can see that the RHS side is equal. The angle 3 plus angle 4 is equal to 180 degree. And the same way angle 1 plus angle 2 plus angle 3 is equal to 180 degree. So when you compare these equation 1 and equation 2, we can write angle 3 plus angle 4 is equal to angle 1 plus angle 2 plus angle 3. Then there will be a common factor angle 3. Angle 3 and angle 3 will be cancelled. When you take this angle 3 to the side, positive will be negative, then it will be cancelled. Then what is left here? Angle 4 is equal to angle 1 plus angle 2. We got angle 4 equal to angle 1 plus angle 2. We know that angle 4 is an exterior angle of a triangle PQR and angle 1 and angle 2 are interior angles. Angle 1 and angle 2 are interior angles. That angles are opposite to angle 4. Is it? So, exterior, we will get the result like this. The exterior angle of a triangle is equal to the sum of the interior opposite angles. Angle 1 and angle 2 are just opposite to the side PR. This PR forms a exterior angle, that is angle 4. So, sum of these interior opposite angles are equal to an exterior angle. So, this result can be stated in the form of a theorem. That is theorem 6.8. If a side of a triangle is produced, then the exterior angles are formed is equal to the sum of the interior opposite angles. Using this theorem, we can solve some problems also. Suppose angle 1 is equal to 62 degree and angle 4 is equal to 54 degree. Two interior angles of the triangle is given and that is just opposite the exterior angle. So, using the theorem we can find angle 4. Here angle 4 is equal to sum of these two angles, sum of the interior opposite angles. So, angle 4 we know that angle 4 is equal to angle 1 plus angle 2. That means 62 plus 54 which is equal to 160 degrees. So, angle 4 is equal to 160 degree. And if you know this exterior angle, you can find out this angle that because they are linear pairs. So 180 minus 160, you will get this angle 3 also. Other ways you can use the angle sum property. Two angles you know it. So sum of these three angles is equal to 180 degree. So angle 3 is equal to 180 minus 160. 52 plus 54 plus 62. Let us do some problem using theorem 6.7 and 6.8. The first question is, in the figure, if QT perpendicular to PR and angle TQR is equal to 40 degree and angle SPR equal to 30 degree, find X and Y. So in the figure it's given for you QT perpendicular to PR. QT perpendicular to PR. That means this angle is equal to 90 degree. And it's given for you triangle angle TQR. Angle TQR is equal to 40 degree. Angle SPR equal to 30 degree. So first of all, you identify the triangles in the picture. So how many triangles you can see there? Angle TQR is in the triangle TQR and angle SPR in the triangle PSR or SPR. This is the triangle. Observe these two triangles. In triangle TQR, can you identify the angles? In this triangle, you can see there are two angles are given. One angle is 90 degree, another angle is 40 degree, and the third angle we want to find. That is angle TQR. This is the triangle TQR. So two of the angles are given. We want to find the third angle. So very easily you can find out using theorem 6.7. We know the theorem 6.7 is angle sum property. Sum of all angles of a triangle is 180 degree. Two angles is given. So we are able to find the third angle. So we can write here 90 degree plus 40 degree plus x equal to 180 degree. The reason is angle sum property. So we will get the value of x. X is equal to 180 minus 90 plus 40, 130 degree, which is equal to 50. So angle x is equal to 50 degree. So one of the angle we got. Next we want to get angle y. Observe this angle. What type of angle is angle y? When you observe the triangle PSR, angle y is the exterior angle of this triangle. If you draw separately PSR, if we produce the line RS to the point Q, and this angle is Y, is it? So angle Y, this angle is the exterior angle of this triangle. And this angle SPR is given for you, that is 30 degree. We want to find this angle Y. Now we already find out what is angle X or angle R, that we got it 50 degree. So choose angle, interior opposite angles we know it. So very easily you can find the exterior angle using theorem 6.8. If a side of a triangle is produced, then the exterior angles of formed is equal to the sum of the two interior opposite angles. So here we can write in triangle SPR, angle Y is equal to angle SPR plus angle PRS, or you can write here 30 degree plus X. So angle Y is equal to 30 degree plus 50, which is equal to 80 degree. So the exterior angle is equal to 80 degree. Here you should write the reason by theorem 6.8 or exterior angle property. The next question is, in the figure, sides QP and RQ of a triangle PQR are produced to points S and T respectively. If angle SPR is equal to 125 degree and angle PQT is equal to 110 degree, find angle PRQ. So in this question, two exterior angles are given for you. You want to find the interior angle PRQ. Here, using the exterior angle property, you are able to find this interior angle because they are linear pairs. Here also you can find this angle. And then you can use the angle sum property. Or you can use one of the interior angle you find, then you can find the exterior angle property. So let's see here, We know that angle PQT, that is the exterior angle, PQT, which is equal to sum of the two interior opposite angles. That is angle QPR plus angle PRQ by theorem 6.8. An exterior angle of a triangle is equal to sum of the two interior opposite angles. The angle QPR we don't know, and angle PRQ also we don't know. But you can find out angle QPR. Angle QPR you can find out because this angle is given. These two angles are linear pairs. So we will get the angle QPR. So first of all we can find angle QPR is equal to 180 minus 125, or you can write here angle QPR plus 125 is equal to 180 degree. There is a linear pair. Therefore, angle QPR is equal to 180 minus 125, which is equal to 55 degree. QPR equal to 55 degree. So we can find out angle PQT. It's already given for you. Angle PQT is already given for you. You can substitute that. Angle PQT is equal to 115 equal to QPR, that is 55 degree plus angle PRQ. So angle PRQ is equal to 115 degree minus 55 degree, which is equal to 60 degree. Angle PRQ is equal to 60 degree. In the figure, the side QR of triangle PQR is produced to a point S. If the bisectors of angle PQR and angle PRS meet at a point T, then prove that angle QTR is equal to half of angle QPR. In this question, it is given that angle PQR and angle PRS are bisected by the QT and RT, and these two bisectors meet at the point T. And we want to prove that angle QTR equal to half of angle QPR. Are you able to identify these two angles in the figure? See, angle QTR, this is angle QTR, this is angle QPR. We want to show that angle QTR is equal to half of angle QPR. So first of all, you want to identify what all things are given in the question, or what all things are given for you. The main thing is it's given QT is the bisector of angle PQR. That means angle PQR is divided into two equal halves. So angle PQT equal to angle TQR. These two angles are equal. Sum of these two angles is equal to angle PQR. So angle PQT equal to angle TQR. Sum of these two angles equal to angle PQR. So we can say that angle PQR is equal to double of angle TQR. And the second case is RT is the bisector of angle PRS. Angle PRS is an exterior angle of triangle PQR. If you draw these triangles separately, if you draw triangle PQR, that QR is extended to the point S. So PRS is the exterior angle of triangle PQR. and this angle is bisected by the line RT. That means these two angles are equal. So angle PRT equal to angle TRS. These two angles are equal now. So we can say that double of angle TRS is equal to angle PRS. And if you consider triangle TQR, you can draw triangle TQR separately. TQR. The TRS, angle TRS is the exterior angle of triangle TQR. TQR, and this is the exterior angle. Angle TRS is the exterior angle of triangle TQR. So in both the cases, we are able to use the theorem 6.8. It is exterior angle theorem. And first of all, you have to write what is given and what you have to prove. Then you should write the proof. So the given thing is QT and RT are bisectors. Bisectors of angle PQR and angle PRS. Then to prove, angle QTR is equal to half of angle QPR. The next one is proof. When you are writing the proof, first of all, you should consider the triangle PQR and triangle TQR separately. If you consider triangle TQR, we know that TRS, this TRS is the exterior angle. So angle TRS is equal to sum of two interior opposite angles. So the sum of two interior opposite angle of this angle is angle QTR and angle TQR. That means if you take this triangle separately, this angle is equal to sum of these two angles. That is angle 1 and angle 2, you can mark it. That is QTR plus TQR. So angle QTR plus angle TQR. Exterior angle is equal to sum of two interior angles. Here we want to get angle QTR. This angle only we want to prove. So from this you can write angle QTR is equal to, keep this angle here, the other you can take to this side. So it will be angle TRS addition is going to this side, then it will be subtraction minus angle TQR. This is our equation 1. The reason is exterior angle property, or you can write theorem 6.8. From this we find out what is QTR. QTR is equal to TRS minus TQR. That means QTR, that is one of the angle. If you know the exterior angle, one of the interior angle, you can find the other interior angle. Exterior angle minus interior angle. So angle TRS minus angle TQR equal to angle QTR. You can give it as equation 2. Similarly, consider triangle PQR. In triangle PQR, angle PRS is the exterior angle. Angle PRS is the exterior angle of triangle PQR. So angle PRS is equal to angle QPR plus PQR, sum of these two interior opposite angles. Angle PRS equal to angle PQR plus angle QPR. And now we know that angle PQR is equal to sum of these two angles. That means angle PQT plus angle TQR, or you can name it as angle 1 and angle 2. And we know that angle 1 is equal to angle 2 because QT is the bisector of angle PQR. So we can say that angle PQR is equal to angle 1 plus angle 2. They are equal. So we can write it as 2 angle 2. Is it? Double of angle 2 because angle 1 is also equal to angle 2. Angle 2 plus angle 2, 2 angle 2. And the same way, angle PRS. Angle PRS, you can mark these two angles as angle 3 and angle 4. Angle 3 is equal to angle 4 because RT is the bisector of angle PRS. So angle PRS we can write angle 3 plus angle 4. Angle 3 plus angle 4, that means angle 3 you can write it as they are equal. So angle 4 plus angle 4, that is a 2 angle 4. Here angle 4, which is the angle name? TRS. Angle 2, the angle TQR. So instead of the number you can give the name also. So angle PQR equal to 2 angle 2, that means 2 angle 2. The name of angle 2 is TQR. 2 angle TQR. And angle PR is equal to 2 angle 4. That means angle 4 name you can give it 2 angle 4. Angle 4 is TRS. Angle TRS. So we got angle PQR is equal to double of angle TQR. Angle PR is equal to double of angle TRS. So we got what is angle PRS and what is angle PQR. Substitute these two values in this equation. You can give this equation as equation 3. What is the reason? By theorem 6.8 we are getting this because we are using the exterior angle property. Now we find out what is angle PRS and what is angle PQR because it's given for you. QT and RT are the bisectors of these two angles. So we got what is angle PQR and what is angle PRS. Substitute these values in this equation 3. So angle PRS, instead of angle PRS you can write 2 angle TRS equal to angle PQR. We already know what is angle PQR, that is 2 angle PQR plus angle QPR. We just substitute the value of angle PQR and angle PRS in this equation. Now keep this QPR there itself, take this angle PQR to this side. Then it will be 2 angle TRS minus 2 angle TQR is equal to angle QPR. Now, in both the terms 2 is common, you can take it out. So 2 into angle TRS minus angle TQR is equal to angle QPR. Now look at the equation 2. Already we find out angle TRS minus angle TQR equal to angle QTR by using equation 1. So substitute equation 2 in this equation. Substitute equation 2. Then it will be 2 into angle TRS minus TQR equal to angle QTR equal to. So instead of this we substitute equation 2. We know that the difference of these two angles is equal to angle QTR. So 2 angle QTR equal to angle QPR. We just substitute this as angle QTR. So 2 into angle QTR equal to angle QPR. Now we got angle QPR is equal to double of angle QTR. What we want to prove it? We want to prove that QTR is equal to half of angle QPR. So when you take this 2 to that side, angle QTR is equal to, the multiplication is going to that side, then it will be division. Angle QPR by 2, that is half of angle QPR. So hence proved. Angle QPR is equal to half of angle QPR. So children, I hope that you understand this question. So when you are writing this, you have to pause the video and look at the figure. Draw the figure and look at the figure and identify each step. Identify each angle and write step by step. Otherwise, you feel, when you are reading these all angles, it will be confused. So each step, by look at the figure, identify the angle, then write each step. See the next question. In the figure, angle x is equal to 72 degree. Angle XZY is equal to 46 degree. If YO and ZO are bisectors of angle XYZ and angle XZY respectively of triangle XYZ, find angle OYZ and angle YOZ. So in triangle XYZ, two of the angles are given, angle X and angle Z is given. Angle X is equal to 72 degree, angle Z is equal to 46 degree, that is angle XZY. So we can write in triangle XYZ, angle X is equal to 72 degree, angle Z, that means angle XZY equal to 46 degree. We can, if you know two of the angle, we can find the third angle using the angle sum property. So your third angle is angle XYZ. So angle X plus angle Z plus angle Y is equal to 180 degree. So angle X is equal to 72 plus angle Z, that is angle XZY equal to 46 plus angle Y is equal to 180 degree. So angle Y is equal to 180 minus 72 plus 46, that is 118, which is equal to 62. So angle Y, that means angle XYZ equal to 762 degree. Angle XYZ, that means the whole angle. This whole angle is equal to 62 degree. We want to find angle YOZ and we want to find angle ZYO. If you know the whole angle, it's already given for you. YO and ZO are the bisectors of these two angles. YO is the bisector of angle XYZ. That means it divides the angle to two equal halves. And ZO is the bisector of angle XZY. So it divides the angle to two equal parts. The whole angle we know it, then the half we can find out. So angle ZYO or OYZ is equal to half of angle XYZ or half of angle Y, which is equal to half of 62, that is equal to 31 degree. So OYZ equal to 31 degree. Similarly, you can find out angle OZY. OZY is equal to half of angle XZY. That is half of angle Z, which is equal to half of 46. That is equal to 23 degree. So now you know this angle is equal to 31 degree and this angle is equal to 23 degree. The next question we want to find YOZ. If you consider this triangle YOZ, two of angles unite, then you are able to find the third angle using angle sum property. So in triangle YOZ, angle YOZ is equal to, or you can write here angle YOZ plus angle OYZ plus angle OZY is equal to 180 degree. Therefore, angle YOZ equal plus OYZ equal to 31 plus OZY is equal to 23, which is equal to 180. So, angle YOZ equal to 180 minus 31 plus 23, which is equal to 54. So, angle YOZ equal to 180 minus 54, which is equal to 126 degree. So, dear students, we have studied so many theorems and two axioms also. Just to revise this all, we just complete this chapter. So, first we have studied linear pair axioms. Then we have studied one theorem, that is related to vertically opposite angles. Then we have studied corresponding angles axioms and its converse also. Then we have seen a lot of theorems. Theorem 6.2, 6.3 like that up to theorem 6.8 we have studied. So you should study these all theorems thoroughly. And using these theorems we solve a lot of problems. You have to write and study each example questions and exercise questions 1 or 2 times. Again and again I am repeating. You should write and study exercise problems and examples problems given in the textbook. Today's your worksheet is exercise 6.3, question number 1, 3, 4 and 5. So first of all you have to study these questions what we discussed in the class. You should write all these questions in your notebook. Afterwards you write your worksheet. So we completed this chapter. Revise that axioms and theorems and all the questions in the textbook. Thank you.